On the section 9.2 homework, the first 3 questions are addressed in the lesson video. I will leave it up to you to watch the lesson video and answer those questions, starting with question number 4. The instructions in the problem are to solve the equation S times P equals S. And although I do that for you in the lesson video, it is a much longer process than what I show you using the TI graphing calculator. So here's what we will do. On our TI-84, we will enter the matrix. Then we will exit to the home screen. We will take the matrix that we just entered and raise it to some large power. Now this is where you can use whatever power you like. You can try something really big like 5 or 6 or 7. However, if you just cut right to the point and use an exponent such as 50, you probably will not have to try it again, and your calculator has no issues doing it to the 50th power, as we would by hand. Now, if I get the rows of this matrix identical, then we have found the correct stationary matrix. If not, I try a bigger exponent. Now, in the first part of the question, we're asked for the S. The S will be either of those rows of this matrix. So we will enter the 1 by 2 matrix that has a 0.5 and a 0.5. And the second question for the P with the bar over it, that is the matrix that we just got on our calculator, which would be the 2 by 2 matrix with the 0.5, 0.5 in both rows. Question number 5 is the same thing, so we will do the same process. Take out our calculator, go to the matrix editor, and enter our matrix. After entering the matrix, make sure you check each element, because one mistake and you'll be getting the wrong answer. Just like before, we exit to the main menu. We do that matrix raised to some large power. Now, since I just did the A matrix raised to the 50th power, and I just typed my new matrix as A, I can simply press the Enter key. And again, as long as all 3 rows are identical, then we have found the stationary matrix. And so just like before, we want to enter that into, first off, the S matrix. In the instructions, they ask us to round to the nearest thousandths. That means 3 places past the decimal. So let's see, we will have a 0.25, a 0.417, and a 0.333. So we'll have a 1 by 3 matrix. And as before, this will be the 3 by 3 matrix that has all the rows identical to what we just typed. Question 6 is asking us to compute specific powers of the transition matrix. So we will take out our calculator, enter this matrix, and do it to the 4th power. After checking the numbers, we go back to the home screen and do matrix A with an exponent of 4. Now, as you see, the rows are already fairly close together as far as the numbers. However, we will need to type that accurate to 4 decimal places. As I said, on the higher powers, we can just skip right up to something like 50, and the calculator has no issues with that. So on my TI-84, if I go second, enter, it calls back what I just typed. Scroll to where I have a 4 and type 50. Now, as you can see, to 4 decimal places, well, in fact, to 10 decimal places, those numbers are identical. This is a repeat of a problem we had in the previous section, only there's a new question this time. I'm going to go through this fairly quickly since we just did it in the previous section. In the first part of the problem, we're told that in the beginning, 42.4% of the households were homeowners. So our initial state matrix, S0, is going to be, we'll use H and R in that order. They use A's and B's, but it's the same. So this was 42.4, which would make 57.6. In the next sentence, it tells about our transition. So now we will fill in our transition diagram and transition matrix. Now I'm going to go ahead and write H and R for these. And we would have 16.4% of homeowners became renters. So that would be, I'm going to go ahead and write this and then I'll come back and fill it in. The homeowners became renters. That would be 164. We're told that 17.9% of renters became homeowners. Here are the renters, and they became homeowners. So this is the 17.9. Now in the first row, if 16.4% are homeowners that went to renters, then the rest would be 1 minus that, or 83.6%. And likewise, if the renters to homeowners is 17.9, then the renters to renters would be 1 minus that, or 82.1. And so there's our transition matrix and our initial state matrix, which we will need to answer the remaining questions. In my calculator, I'm going to use an A and a B for those two. Now I'll type those into my calculator. So after entering the initial state matrix and the transition matrix as A and B respectively in my calculator, we're prepared to answer the questions. The first two questions are duplicates of the previous section. What percent of households were homeowners in 2010? I'll just remind you that a census is done every 10 years. So 2010 would be the first state. So we need to do A times B. And the first number in the matrix is the homeowners, and so that's what we're going to use for our answer. As a percent, rounded to the nearest tenth, that would be 45.8. So likewise, the second question was right from the previous section's homework. So what percent were homeowners in 2030? That would be the third state from the original census. So we would do A times B to the third power. If I go second, enter, and put an exponent of 3. And again, we're looking for the homeowners, which is the first number. Now the new question here is the deep question. In the long run, well, after what we've been doing, let's say that the long run consists of 50 censuses. Now that'll be 500 years. So I think that's a fairly long run. So on our calculator, if we do A times B to a large power, such as 50, then the first number is the households that are homeowners. That would be 52.2. And the second number would be the renters. The last question, likewise, is one that we had similar to in the previous section. We pick out the correct transition diagram. We write that as a transition matrix. And the only question this time is what we're learning in this section, and that is, what about the long run? Now I'm going to go ahead and go through parts A and B. Now we'll enter the transition matrix on our calculator. After double checking our numbers, we exit and do matrix A to some large power, and we have rows that are fairly identical, at least to the nearest tenth of a percent, as it says in the problem. So any of the 3 rows provides us with our answers. So A would be 5.9, B 3.5, and C 90.5.